Before we do any labs, we have to talk about safety. During labs, we might be dealing with things called acids and other chemicals. If you get those in your face, it will hurt. Because of this, we need to wear goggles.
Is this the proper way to wear goggles? Is this the proper way to wear goggles? Is this the proper way to wear goggles? This is the proper way to wear goggles.
Now, what happens if your partner slaps the goggles out of your face and gets some acid in your eye? Because who knows what your partner's gonna do? Well, what you do is you go to the eyewash station. The eyewash station is something that will wash your eyes in case you get acid in them. What you do is you calmly have your partner bring you over here. You put your face over the eyewash station, open your eyes, pull the handle, and wash your eyes for a long, long time. While you do that, have your partner come get the teacher. What happens if you get acid on yourself? Well, take a look right there. There is a wash station. Let's go take a look at it. Wait a minute, Mr. Jones. Your goggles are not on right.
Oh, sorry about that.
This is the wash station. If you get any sort of chemicals on you, you come over here and you pull the handle. If you do get any sort of chemicals on yourself, definitely talk to your teacher, and then we will decide what's best. If you get acid on your hands or chemicals on your hands, what do you do for that?
You use the sink.
You use the sink, and there's some soap right there. Don't even ask, hey, I got chemicals on my hands, what do I do? Just say, I need to go to the sink right away. Go to the sink calmly. Remember, you don't need to sprint, because fast is slow and slow is fast. So come over here, wash your hands, and while you're washing your hands, say, hey, Mr. Dato or Mr. Jones, we got something on our hands.
Also wash your hands for 20 seconds.
Now let's go through the different types of glassware you'll see during a lab. Obviously, this is not glassware, but these are safety goggles that you need to wear at all times. The only time you ever take these off is when the teacher says so.
This is a beaker meant for holding things.
Do we measure with a beaker, Mr. Jones?
No, we do not.
We just hold things in it. This is a graduated cylinder. This is something that we measure things in.
This is a scoopula. It's for scooping.
This is a test tube and a test tube rack to hold the test tube. There are different sizes of test tube. This is a medium one.
This is a pipette. It's meant for pipetting, sucking up liquids, holding
And
liquids,
dispensing them.
and dispensing liquids.
This is a dropper bottle, and it has a dropper. We can add some chemicals here that we can use to then dispense out at a later time.
This is a funnel. You should know what funnels do.
This is broken glass. This is something you do not touch if you ever happen to see broken glass. Instead, call your instructor right away.
This is a glass stir rod. It's meant for stirring.
This is an Erlenmeyer flask. It's used to hold different sort of chemicals.
So here we have milk and Red Bull. I'll take a pipette of milk, put it in this test tube. It's a full pipette of Red Bull. And then a pipette of Red Bull.
And maybe one more.
And maybe one more, just so you can actually see what's really happening in this tube. I'm going to stir it up now so you can see the difference. You can see
Chunky.
it is chunky. You can see the particles floating around in it. is clearly different from either the milk or the Red Bull that it started as.
You can really see it separating. This is a filter with some filter paper in there. And underneath, we've got a beaker.
This is the test tube from the previous experiment. We are now going to pour this over the filter paper.
And there we go. It's dripped down to the bottom here, and it doesn't have the chunkiness anymore. All right, we've got yellow and blue, and what we're going to do is mix them together and we get green. This is actually not a chemical change, but a physical change because it was an expected color change. The mixture of the two colors is what created a new color. There's no new substance. Here is a strip of magnesium metal. We're going to take the strip of magnesium metal and put it inside of some hydrochloric acid, and we're going to observe what happens. If you take a look, you can see it's producing a lot of bubbles. It's also getting pretty hot. After a moment, you'll see that there's no more magnesium. Now, what I will say is, it looks as if the magnesium was dissolved. However, it wasn't dissolved, which is something that we'll talk about in the future. Here we have a seashell, and here we've got hydrochloric acid again. What we're going to do is we're going to see what happens when we put that on the seashell. Whoa, bubbles. You can see what looks like smoke coming off of there, but is it actually smoke? Here we've got some water. Here we've got some boiling water. And notice over time, the water level goes down.
This is a physical change because the identity of the water has not changed. It is still water in vapor form as opposed to liquid form. Therefore, it is a physical change.
Whoa. This is a piece of magnesium ribbon. This is a metal. What we're going to do is we're going to take that metal and we're going to put it in a flame. Do you think that it will catch on fire? Okay, oh yeah. I'm going to pull it out. Whoa! Was amazing. Yeah, it's boring. We've got sodium chloride, which is table salt, and we've got water, which is hot because it was the boiling water. And we're going to take this table salt and put it in the water and observe what happens. Now you can see the little salt crystals at the bottom there, but notice how they are actually disappearing. And if you waited long enough, there would be no more. Although the salt is disappearing, this is actually a physical change because the identity of the salt does not change. And the way you know that, if you were to taste the water, it'd be salty. The other way to think about it is, can you get the salt back? And the answer is yes, you can get the salt back if you were to evaporate out all the water. This is sodium bicarbonate. This is acetic acid. The liquid in here is acetic acid, and we've taken this sodium bicarbonate and have put it inside of this balloon here. And the balloon is on top of the flask, sealed. So let's see what happens when we add the sodium bicarbonate to the acetic acid. Whoa! And that's why we wear goggles.